All right. As far as I can tell, I am now live with you on YouTube. So if you are with me, go ahead and type in the chat. Let me know that you're here. Maybe tell me a little bit about yourself in terms of what you teach and where you are. Uh, and then we will get started here in a moment. All right. As far as I can tell, I am now live. I know there is a slight delay between what I see on my screen and what you see on your screen. So again, if you're with me here, I think we've got a few people in there. Go ahead and just type in the chat. Let me know that you're here, where you're from, what you teach, and then we will get this show on the road and start playing with math and hopefully leave you with some decent ideas and thoughts for how to start the year off right, obviously, in math class, which is what we're all here for. And thank you. I can start. I see some stuff in the chat now. So thank you guys for being here and joining me. I know some people signed up from faraway places, and maybe it's nighttime over there, so they're going to join and look in the chat and maybe even just take a look at this later. So again, thanks. And let me make sure I get all my technology working. This is only the second time I've ever done a YouTube live, so bear with me. I'm definitely going to use the chat. I want to hear from you. I want to make this as much of a dialogue as I possibly can in this format. And I hope that you guys are ready to play with math. I see we've got some 4th, 5th, 6th grade curriculum specialists. We've got everything here, so that's awesome. And here we go. So let me share my screen. And you should be seeing here in a moment, just a little slide there. There's my contact information for those of you who don't already have it. Most of you probably do, but you can always email me at drrajshaw@me.com and tweet at me at drrajshaw. So with that, let's get going. So many of you know who I am, but I live in Central Ohio. I own a business called Math Plus Academy, where we teach math to kids after school. I like to say it's the perfect complement to school. And I just I'm also part of the Global Math Project. For if anyone hasn't looked that up, definitely check out globalmathproject.org. Amazing stuff there, free resources to also bring joy and love of math into your classroom. And with that, let's go. So I always start off with this one slide, which is the one that motivates me the most, which is the idea that when you survey kids, 56% of them would rather eat broccoli than do math. And I just find this shocking, disappointing, scary, and motivating, because I don't think that math should be losing to broccoli. And that's what we're going to talk about today. As always, if you've seen me, you know that's kind of where I always start, is how do we make math seem like it isn't broccoli? Goodness gracious. And for me, that means my job is to try and make math irresistible for kids and for teachers. I know that sometimes school math doesn't always feel super exciting and super irresistible. And so that's what we're going to tackle. All right. So the beginning of the year is an awesome time to establish your classroom culture, to hopefully get kids start on the right foot about thinking differently about math if they have some negative feelings about mathematics already. And for those who like it, to just, solidify that even more, to make it engaging for them, to let them see that math is about collaboration. I don't know about you, but certainly when I was growing up and doing mathematics in school, I always thought it was a individual sport that you could only do it by yourself. And if you did it with someone else, it was kind of like cheating. I now have learned through experience that isn't the way it should be. And when you collaborate and you let kids work together on things, it's just everything gets so much better. It gets easier. It's really helps students who have anxiety and things like that when it comes to solving problems, because then they can work with other people and figure things out. And you get to learn from other people, which is amazing because everybody thinks in different ways. And you get to see things from a different perspective that you could never see if you only did math by yourself. And then, of course, to reinforce the idea that math is about thinking and not just getting answers as quickly as possible. So, beginning of the year is a great opportunity to do that because we don't have necessarily just yet the pressure of like getting through all of the skills and making sure they're ready for the year-end tests and all that kind of stuff, standardized testing. So I hope to share some of my favorite problems with you. These are problems that I have found rarely sort of fail. Like kids seem to naturally get into them, and we'll talk about how to launch them and where the math is and how to tie things back together and all that kind of stuff. So our job as math educators is to try and craft irresistible experiences. A lot of times people come to me and they say, where do you get these great problems? How do you find these things? And certainly some problems are better than others, but a lot of what makes a problem great or makes the experience great is how we launch the task, what we do to facilitate it, to enable them to figure things out when they get stuck, the questions that we ask, just everything about it that is independent of the actual problem itself. So I always want to talk about those things as well as the math that's in the problem. And my checklist for like beginning of the year is, this is certainly not a comprehensive checklist, but a basic checklist is I want to make sure that I'm picking some stuff that is going to either and or spark curiosity, make them surprised about something, or enable them to play, just to feel like I'm playing a game and not being forced to do something against my will. If I can make it feel like a game, then everything is sort of relatively smooth sailing from there. I'm also trying to focus here on tasks that I can make or I can help students make really visual or hands-on. If we can get up and move, we can act things out, we can start to draw pictures. That generally is much more exciting than sort of grinding through arithmetic or algebra or something like that. If you see me present before, I talk a lot about the dynamics of video games and how the best video games always start ridiculously easy, like level 1 of Tetris. When people talk about rich tests, they talk about low barrier to entry. Either one of those is fine. I'm trying to find ways to introduce these tasks where every single person in the room can at least have something to contribute to the conversation and not feel like, oh gosh, here we go again. Math is hard and I don't know what to do. Again, picking problems here where there's many different ways to solve them, so we can compare and contrast all that stuff. That they're very open, and then they're easily extendable because you will have students or groups that finish quickly, and then what do you do with them? And where can we extend the math and keep the thinking going as long as possible? Trying to find ways to basically never have it end. Like there's no end, it just keeps going. So if you could type in the chat for me, what are some hopes, expectations, and goals you have for the next hour and change that we spend together here on YouTube? That would be fantastic. I have some that I've come up with, but I'd love to hear from you first. And again, we're on a little delay here, so let's give ourselves a few seconds to go ahead and punch some stuff in the chat. Let me know what you're hoping to get. Okay, I'm not seeing anything in the chat. I'm not sure if it's because there's a delay still. Okay, I got one. This is good. Thanks, Mallory. Appreciate it. Inspiration. Let's do it. Okay, incorporating strategies. Awesome. Yeah, make the kids who normally don't find this math uh, a positive place to like change that right off the bat, or at least start making progress on that. Learning concrete. Yeah. Okay. Excellent. Those are pretty well aligned with mine too. So, um, first of all, I want us to play around with math. It's going to be a little bit tricky through the YouTube live platform because I can't be there with you and see your thinking and talk to you as clearly as I would in a classroom or even in a typical Zoom. But we will do our best. I'm going to ask for some volunteers to help me play with that math, and we'll try to make it work through our YouTube live scenario here. Yeah, all right. Oh, willingness to take risks. I love that. Yeah, we're going to work on that too. I'll give you some options for how I have done these tasks, how I've launched them, and what's worked for me. I certainly don't have all the answers, but hopefully some ideas that may be helpful for you. And if you have ideas or if you've done these tasks before and you have something that worked, please, please, please share it in the chat so we can all learn. Maybe we may talk about some common sticking points where kids get stuck on these problems and what you can do to keep their hope of success going so they can keep moving, and how to take it and make it relevant for your grade level. So we have a pretty wide grade band here. I said 2nd to 8th in my invitation. It seems like we're kind of in the 4 to 6, 4 to 7 range from what I can tell in the chat. But how can you tune it, exactly to the right level? Okay, great. Let's get into some math. Enough of me talking. I'm tired of hearing myself talk. I want to make this choose your own adventure. So I prepared 5 problems, and if we have time for more, I'll do more. These are some of my 5 favorite go-to math problems that every time I launch them, by and large, I get a pretty positive reaction, no matter what the group of students are. So type for me if any of these looks intriguing to you, or it's one you haven't seen before. Pop that in the chat, and we'll just kind of try and go by majority rule here and drop into some of these tasks and see how it works. All right, tax collector. All right, 2 votes for the tax collector. And those of you who voted for tax collector, have you done this problem before? So, oh, wow. All right, and then maybe we'll get to take the last one. Okay, cool. So let me stop sharing this. Hang on while I manage my technology here. And I'm going to share my iPad so we can play around with this. Okay. All right. So hopefully you guys can see my whiteboard screen here. What we're going to do is we're going to imagine a world where you're working at some job and you have to pay taxes. This is an imaginary world. And there are these paychecks that are worth anywhere between $1 and $12. So we'll put these on the screen. And the way this is going to work is you get to choose any paycheck that you want. But every time you do, you're going to have to pay taxes on that paycheck. And the way taxes work is the tax collector. So there's you're going to collect your pay. And there's our tax collector who's going to take tax. And the tax is going to be all the factors that are left on the board here, 1 through 12, of the number that you choose. So for example, let's say right off the bat, you're like, well, of course, I want the $12 check. no problem. I can give you the $12 check. But as myself being the tax collector, I'm going to collect all the checks on here that are factors of 12. So then I will collect the 1 and the 2 and the 3 and the 4 and the 6. And so on my side, I will get all of these. Okay, so that's how this problem works. And then we just keep going until there are no checks left. Now there's two technical rules here. One is you always have to choose a check that allows me to collect a tax. So for example, if we're in the situation where you've taken 12 and I've taken all of those, you could not on your second turn take the 5. And you can't take the 5 because there are no factors of 5 left on the board. The only factor would be 1, and I've already taken that. So that is now not an option for you. So we're going to go like this. At some point, there will be no checks left that you can take because there are no factors left for me to collect. At that point, because life isn't fair, and this is how taxes work, I get everything that's left. Okay. And then you can guess what the goal is here. The goal would be for you to get more money than me. So that is tax collector. And the way I usually start this after I explain the rules is just to pick on a volunteer or to randomly go around and have students tell me, okay, you're up. What would you like to take first? And we just play around together. So I try to make this work in the chat. Could someone, and I'll just take whomever I see first, tell me what check you would like to take first? Pretend like you're a student. Don't think about this too hard. We're just going to play around with it, see what happens. All right. Awesome. Angela, you're the first one to pop in the chat. You said take the 6. All right. So I'm going to give you the 6. In the meantime, Angela, tell me what you would take next. Oh, good. Now I'm seeing stuff pop in the chat. So if we give you the 6, that's cool. Factors of 6, 1, 2, and 3. So I will take those. Thank you so much. Those are for me. And after sort of round 1, we're kind of even. You have 6 and I have 6. All right, let me see. Just scanning the chat here. What could you take next? See, a couple people are saying 11, so I'm just going to say, oh, E. You cannot take 11 now because the only factor of 11 is 1, and the 1 is gone. Bummer. What is something else you might take now? So 11 is kind of off the table. 10. Okay, 10. Awesome. Yeah, we should go for high numbers, right? So you take 10. I'll give that to you. And let's see, factors of 10, 1 and 2, but those are gone. So 5. 5 comes to me. I will take 5. Thank you for that. And this is good. In this round, you kind of gained ground on me. Nice. Okay, 8. I see 8 in the chat. Let's take 8 next for you guys. That's 8. And that does give me the 4. Obviously, depending on your students and their sophistication with factors, this could take more or less time. I'm going to, for now, because of this format, I'm just going to assume we know our factors. So 8 gives you 4. Can you take anything else? It appears to me like you are now stuck because 7 only has 1, 9 has 3 and 1, which are gone. 11 has 1, 12. Yeah, it feels like unless I'm doing something wrong, this is it. You're done. Now, good news for me as tax collector. It's fun to be tax collector. I get all of these at the end. So 7, 9, 11, 12. 7, 9, 11, 12. So we might play around like this together. And then I can ask you, do you even think it's possible that you could get more money than the tax collector? And I can imagine A lot of students would say, no, this is impossible. Some will think, well, if he's asking me this question, it must be possible. And then we might play a few rounds again to try different things. We might start to notice, does the order in which you take things matter? Like, should you take the 12 first or last or somewhere in between? Does it make a difference? So we want to talk through some of those things. And then if you feel comfortable, like everyone kind of gets how this game works, then I usually will divide them into teams of 3 and let them play and explore this for a little bit on their own as I walk around the room. Oh, sorry. Yes, you do add up the numbers for each team. I apologize for not doing that. So we're going to add these up. On the left, on the U side, you have 24. I didn't add them up because it was obvious that I won. 6, 6 and 9, 15, 22, 31, 41, 51, 50, 54. I think that's right. So I won by a lot. Anyway, I was saying I break them into teams of 3. I make one person a tax collector. They can choose. One person is the person who takes the paychecks, the person getting paid. And then the third person can be the recorder and the fact checker, because if we're not completely clear on factors and stuff, that person can make sure that nobody is breaking any mathematical rules. So it's good to have 3 people in a group. 3 is a nice number. We play around with that, kind of go around, observe what's going on, see if anyone's getting close. Now, what can happen, what often happens is students will at some point, what I say, stumble on to the right, not the right answer. They will stumble onto a way to win, but if they're not keeping track of things very well, they won't actually know how they did it or why it worked. So I always, if you do find a way where the person taking paychecks gets more money, I will always try and make them repeat it so that they can prove they actually know what's going on. And then if we get that far, we can then explore lots of additional questions. For example, if you can win, is there like a maximum you can win by? What's the most that you can make and the least the tax collector can make? What does that look like? So let's go ahead and play another round real quick. And you've probably already have some ideas for maybe an alternative strategy. Last time we did 6 first and then 10 and then 8. So maybe think about what would be an optimal first choice. And I know some people had that in the chat already, so you can put that back in the chat and I will just take these highlightings off. There we go. So we're back to a fresh board. So go ahead again, pop in the chat what you might take first and why you would take that first. Okay. Don't forget to tell me why. So I see some stuff in the chat. I don't see any reasons yet. Tell me your reasons. Always love to know how people think. And I will tell you while I'm waiting for answers to come through is by this point, usually kids are really chomping at the bit here, like trying to figure it out. Can we win? It becomes a game, a contest. Can you beat me? I'm the tax collector. Sometimes I amp it up. Like if you guys can beat me by the end of the period, there might be some sort of prize or reward. And certainly a reward is just beating the teacher. So that's always a win. Okay, 11, because it's prime. There are a lot of prime numbers on here, but 11 is the biggest of the prime numbers. And why does that matter? Because then the only thing I can take is the 1 as the tax collector. Okay, so let's go ahead and take 11 first. That seems like a reasonable first try. So you get 11, I get 1. So you're off to a hot start. You're already up by $10. Now, there is a downside, although I guess in round 1, I guess I would get the 1 every time, wouldn't I? So you might as well take the 11. I was going to say the downside is I think I'm going to get all the other prime numbers, or at least most of the other prime numbers. Okay, cool. What would you take next? Another thing you can do, so while I'm waiting for that, another thing you can do that might be helpful is you could hint this, that maybe it's useful to take all these numbers and kind of just give yourself a little cheat sheet chart of what are all their factors, not including themselves. I think the fancy word for that is proper factors. I don't know. It doesn't matter. But like, for example, 12's got lots of friends. 11 only has one. 10 has a few. And this might be useful for them to kind of help them in their thinking. I won't write all of these down, but at least we'll have a few there for reference. And maybe that means I have a lot of ways in which to get the 12 and I don't need to take it first. Okay, I see some stuff coming in the chat. Okay, 9, because you're only going to lose the 3 at that point. That seems like a good option. A couple people saying that. 10 will give me the 2 and the 5. So we can think about, do you want to take 10 now or will you have the opportunity to take it later? I'm going to go with 9 because I see a lot of votes for 9 in the chat. So 9 seems like a good option. We'll give you guys 9. That will give me the 3. Thank you so much. And again, you've gained another $6. You're up $16 on me already. That seemed pretty good. And while I wait for your third check, I will just help you out by popping another few factor tree things on my list here. I may make a mistake, so don't trust me. So yeah, I think the answer to the tax collector always gets 7 unless you take it first is probably true because there are no numbers on here that are multiples of 7. Yeah, I think that's right. I have to think through it a little bit, but that's a good question. Okay, 6. Okay, let's see. Same with 4, only the 2. I'd like to take 6 next. It's the greatest number with only one factor still on the board. Okay, I like the thinking there. 12, Lisa's like, hey, let's get this 12. I want that 12. If you give me the 12 now, I'm going to get 2 and 4 and 6. So maybe you can hold off on the 12. I'm not sure. 6 only gives me the 2. I had a couple of votes for 6. So I'm going to go with 6. Give you the 6. I'll take the 2. There we go. I guess the 3's already gone, right? So I don't get that. All right. What next? Looks like, wow, the 10's an option for you guys. The 8 and the 12 are options also. So things are looking pretty good here. You're off to like a $20 head start on me. Yeah, and I see you guys collaborating in the chat, which is what I love. By the way, you're not really a fair audience because you took time on your Saturday to do math problems with me, but like, are you feeling like this could be a fun task for your students where they can kind of like get into it and start playing around with it? And then also tell me in the chat where you want to go next. Okay, 12 now. Yeah, 12 now seems like a good choice. You kind of have 8 and 12 with both have 4 as their friend. So it seems like you ought to take the 12 and not the 8 because 12 is bigger, obviously. So I'll give you the 12 now. That sounds good. And that gives you the 4. Me the 4. So that's 12 for you and 4 for me. Oh my gosh, I'm down another $8. This is not looking good for me. What's left? I think the only choice you have left is 10. So I'm just going to go ahead and give you the 10 because I'm a nice guy. And I will take the 5. So that gives you 10 and me 5. And that does give me the 7 and the 8 to end off the game. I'm running out of room. So let's do a little magic here. Take these and throw them over there. Boom. And that will give me room to take my 7 and 8. Oops. And let's see, what's my total? 10 and 10, 20. I think I have 30. And that probably leaves you with about 48. Let's see, 20, 30, 48. Okay, you won. Good work. Not bad. Okay, and I see some alternative ideas in there too. So this is great. Yeah, I definitely recommend doing this in team. You could put two kids together to play against someone else or to play against you. You can play a whole class at first against you and then break it down. I definitely recommend breaking it down into smaller groups at some point so that you have everyone thinking and engaging in it versus keeping it whole group, kind of how we're doing right now. Only because of the technology that we have access to right now. But yeah, definitely break it into groups. And then you could bring it back together at the end. Who, oh, we got 48-30. That's an $18 win. That's pretty good. Did anyone beat that? Can you beat this? This is pretty good. You got a lot of the high numbers. You got 9, 10, 11, 12, which are the 4 highest numbers. That's pretty good. You did give me the 7 and the 8. Could you top that is an interesting question. And that's probably where I go next. In terms of extensions, if you do get here, I can tell you right now that you can do better than 48. Believe it or not, there is a better option than 48, although 48 is pretty darn good. And secondly, you could then, another great extension to this is just change the number of checks. You can go like all the way up to 1 to 100. What if I had 1 through 100 up here? What would you take first? And if there are more numbers on the board, is that more opportunities for you to win? Or is that more opportunities for the tax collector to win? Does it get harder to win if you add more checks, or does it get easier to win if you add more checks? I can make an argument both ways. If you give all the numbers 1 to 100, that's a lot of prime numbers, which the tax collector is probably going to get most of them. That seems bad. On the other hand, there's so many options for you that you may be able to navigate through that matrix in a way that gets you to something that is way bigger than the tax collector. I don't know. I don't know how that plays out. You could also try, if you want, if this is a little too overwhelming or too big, you could try a smaller problem. What about 1 through 10 or 1 through 9 or 1 through 6? What would that look like? And then work your way back up to 1 through 12. So this is one of my absolute favorite go-tos. Hopefully you got some inspiration from that if you've never seen it before. It's a really fun problem. It obviously gets into factors, multiples, primes, basics of number theory in there. If you list out all the factors there at the bottom, I think you can help kids too a little bit, or make them list them out. And then maybe tie this back in later in the year when you get some more specific content that relates to this. So that is number 1. I think the next place I got some requests was for us to do take the last one. So this is another really great one. Take the last one. I can't spell this this afternoon. And the way this works is we're going to imagine you can start with any number, but I like to start with 11 tokens. So I would make this hands-on if you have some tokens, some poker chips, whatever it is. You put 11 of them out I like to put them in a row. So 4, 5, 6, 7, 8, 9, 10, 11. And this is a 2-player game. Again, I will usually launch this as me versus the class. And the goal of the game is to take the last token, the last stone, the last circle, whatever it is. It doesn't matter who gets more or less tokens. It just matters who takes the last one. And the rules are pretty simple. We alternate turns, and you can take 1 or 2 on each turn. So we're going to remove tokens from the board, and whoever is able to grab the last token is the winner, following this one simple rule as we alternate. So hopefully that made sense. I think it's only fair if I'm playing against all of you that I get to go first. So I will go first, and I will take 2 stones. So instead of 11, once we start with 11, I'll take 2. I like to take them off the end. It doesn't really matter which 2 you take. You're just reducing the pile from 11 stones to 9 stones. So again, I'm going to go to the chat. I'm going to give all of you a chance to tell me what you would do next. Would you like to take 1 or 2 of the stones that are remaining? And so I'll do one round, at least one round, where it's us, you against me, or the class against me. I like to tell them that I've never, ever lost at this game. And I don't think, I think that helps kind of just draw them in a little bit. Like, what do you mean you never lose? Okay, the first thing I saw in the chat was take 1. So I will give you, or you'll take 1 stone off the board. Now there's 8. It's my turn. I will take 2, leaving 6. And again, this is best done hands-on. So I'll do it in a tactile fashion in the classroom, and then I'll have piles of stones or whatever ready to hand out when we break into small groups, so you can do it in small groups and kids can play against each other. And just like the last game, I'll do 3 in a group. 2 people play against each other. One just kind of keeps track, make sure that everything is working and nobody's breaking any rules. Okay, I see 2 is in the chat, so I'm going to give you 2. That's going to leave 4, and I will take 1. It is your turn. What would you like to do? You may take 1 or 2 stones off the board. Now, depending on the sophistication of your students, some may notice right now that you're doomed. If you take 1, I will take 2, and that gives me the last stone. I win. If you take 2, I'll take the last 1, and I win. So this is a situation where you have no good alternatives. Now, students will say, well, we'll take 3. No, sorry, that's against the rules. You can't do that. That's a different game. That's not the game we're playing. And you can't pass, so you got to do something. I see take 2 in the chat, so I'll go ahead and give you 2, and I will take the last stone. And like I said, I never lose at this game. So that usually intrigues them, usually gets them to want to play again. This is a great little problem-solving task, so we'll play again. I will put the 11 stones back out, and we'll try again. Now, we might note that you probably don't want to let me get you to 3, because we know 3 is a losing scenario for you. You cannot win when there's 3 left. So try and avoid that. Again, it's only fair. It's all of you against me. It's only fair that I go first. I'm going to go ahead and take 2 and leave you with 9. And we'll play this again. I think last time you guys took 1. So maybe you'll take 2 this time. I'll just play it out. So if you took 2, I'll take 1. That leaves you with 6. Now you might take 1 and I'll take 2. Oh, that leaves you with 3. Oh, shoot. We know that's a losing spot for you. So maybe we'll go back 1 turn. Instead of taking 1, maybe you should have taken 2. So you take 2. Awesome. I'll take 1. Whoops. Let me use blue. I'll take 1. And I'll leave you with 3 again. Yeah, this is a game where there's definitely a winning strategy. So now the goal becomes, can you figure out what the winning strategy is? And this is a great example of where working backwards and or solving a simpler problem is a great way to attack this. So once I've got them curious, engaged, again, I might offer a prize for anyone who can actually beat me at this game, because I have never lost. At this point, kids will get a little skeptical about why I always want to go first. Now, I hate to do this, but I think I'm going to go against my normal judgment, and I'm going to go ahead and let you know that if you haven't done this before, that you always want to leave the other person with 3, and you might have started to pick up on this already, 3, 6, or 9 stones, because you can't lose. If you play optimally, you can't lose from those positions. So the goal will be for them to work up to figuring that out. We've already kind of figured out that 3 is bad, and if 3 is bad, then 6 is bad, and you can kind of work backwards from there. So once they kind of start to catch on to that, what I will do, and they catch on to, I'm always taking 2 at the beginning and leaving them with 9, which means from that point on, if I play optimally, I can never lose, because from 9, I can always guarantee that we're left with 6. And from there, I can always guarantee that you're left with 3, and you can't beat me from there. So once we kind of get close to figuring that out, or some groups start to figure that out, what I will do, if I can, and I'm doing this with them, they'll say, well, we want to go first. Yeah, cool, you can go first. And when they're not paying attention, I slip in an extra stone. So now there's 12. I know I'm evil and diabolical. But now, if there's 12 and you go first, you're actually still going to lose. So whether you take 1 or 2, I can still leave you guys with 9. And if they're not paying attention to the details, I can still sneak that in, so I can keep going a little bit longer and keep them off the trail. But my goal is to get them to eventually kind of figure out that 3, 6, 9, 12 are all bad. Then we discover who should go first. You want to be the person that leaves the other person with a multiple of 3. So if there are 12, I should be kind and let you guys go first, because I'm a good person. And that can guarantee that I always win, and kind of just work our way through that. And then what's awesome about this is it's super tactile, easy to learn, easy to play. They will eventually start to figure some things out, so we can talk about those strategies and working backwards and all of that. And then you can vary this. This is actually the game Nim. You can Google this. There are a million versions of Nim. Things you can vary. You could, right now we're playing where taking the last stone is victory for you. We could play that taking the last stone is poison. And if you take it, you lose. Okay, now what's the winning strategy? And what does that look like? Or we might change this rule of, not take 1 or 2. You could actually take 1 or 2 or 3. Now what's the winning strategy? There are versions that are called multi-pile Nim, where you have 2 kinds of stones. Maybe you have some blue ones, maybe you have 5 of those, and maybe you have some purple ones, maybe you have 9 of those. And the rules now are you could take as many blues as you want or as many purples as you want, but you can't take from both piles at the same time. And then what's the winning strategy for that? So there are all kinds of versions. You can just Google Nim and you can find millions of versions of this game. They're really fun to play. They really focus on problem solving and thinking and working backwards. So it's another really good way to start off the year with just an intriguing puzzle. And again, it feels like a game, so that's fun. Okay, somebody asked me about my technology. I am using an iPad with an Apple Pencil. If you have access to that, it's a nice option. And Notability is the app that I'm using. I think it costs a few dollars, but I love it. It smooths out your handwriting a little bit, so your handwriting looks a little nicer. And you can actually have it snap. If you do it correctly, it will snap and make shapes for you. So you can make triangles and squares and things like that. So that's a nice feature. And I also like the highlighter because you can color over things and erase only the highlighting. So it's got the highlighter lives on a different layer than the text. So that's also nice too. So it's got a lot of nice features. Okay. If anyone has any questions or comments about Take the Last One, happy to take those. Otherwise, we can move on to another problem. I think I saw some questions about star polygons. So I want to share that one with you because this one I think can be really, we can get the kids moving around a lot. So if you haven't seen this, this is a really cool one. And again, this is another one where I get kids to engage for a really long time. And I probably would launch this task without actually saying it's called star polygons. What I do is I get the whole class standing up and I get like a beach ball or some soft ball that we can throw around the room. And I have them stand in a circle. I usually stand in the circle as well. And maybe that's 23 people, 28 people. I don't know. It can be a pretty large number, but we're up and moving. And then I'll ask them to pick a number between 3 and 5. Hold on one sec. Okay. We'll pick a number between 3 and 5. And that'll be our skip number. So right now, I'll kind of draw a picture of what that might look like. But just imagine in your mind, all of us standing in a circle. I think there are about 25 of us. So we're standing in a circle and we're just going to throw this beach ball gently around the room. And let's say you pick the number 3. Okay, that's going to be our skip number. So we're going to pass the ball to every third person. And I'm not going to draw 25 people on here. Maybe I'll just draw like 13 people. See if I can do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, in a kind of circle pattern, and I will label them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Whoops, 13. Just like that. And 1 is going to start with the ball. And 1 is just going to pass it to the third person down the line. So skipping 2 and 3, they're not going to get it. And 1 is going to pass the ball to 4. So 1 passes the ball to 4. So we like physically do this in the room. Whoops. So it goes like this. So every third person is going to get it. Now we can imagine who's going to get it next. 7 is going to get the ball next. And then 10, and then 13. And I'll usually stop them right about here. And I'll have the students who have touched the ball raise their hand so we can see who has touched the ball and who hasn't. And right here, I'll just ask them, what do they notice? What do they wonder? Okay, well, we noticed that not everyone has touched the ball. Of course. We noticed that what? 1, 2, 3, 4, 5 people have touched the ball if you include me at the beginning of the pattern. Okay, what else can we notice? Well, there's always 2 people next to each other who haven't touched the ball. Yeah, true. Okay, what questions can we ask? Well, if we keep doing this, will everyone touch the ball? Will they not? Will it come back to me ever? Will it never come back to me? I don't know. So then we continue this process and we throw the ball. So 13 is going to skip 1 and 2. And throw it to 3, 3 throws to 6, 6 to 9, 9 to 12. And right here, I might stop again, pause. What do we notice? Who's touched it? Who hasn't? Oh, wow, twice as many people have touched it now. There's only a handful of people who haven't. Are they going to finally get to touch the ball or not? I don't know. Let's find out. And then we go around and we kind of finish the process. And it does come back to me. And at that point, everyone has touched the ball. So if we start with 13 people and we skip by 3s, then I let the students pick the skip number. I try to make it kind of a smaller number just because it gets tricky. If you're going to skip by like 11, it's hard to do it correctly. And then the whole thing falls apart. So I try to keep the skip number, at least at the beginning, kind of small, especially when I have a lot of students in the room. So we do this a few times. We play around with different skip numbers. It doesn't, if I skip to every other person, will everyone touch the ball? Will they not touch the ball? Then we will maybe I'll take myself out of the circle. So now we'll have 12 people. And then that'll be a completely different set of experiences because 12, lots of numbers go into 12. So if we skipped every 2 people with 12, if we started with 12 and we just went every other person, then only half the people are going to get the ball and half the people are never going to get the ball. Another question is like, how many times does the ball go around before it gets back to the first person? Can we predict that? Is it random? How does it work? So we'll start with that. And then I'll usually ask them, what do you guys, because it's hard to do this over and over again and keep track of what's going on. So could we draw a picture of this? What would this look like? What if we had a drone flying up above and it could kind of see from the top? And then we'll draw this picture so they can start to see what it looks like. And this is really fun. It's very artistic. You get to build these beautiful little star polygons. You can start to predict how many points will it have? How many times will it go around? Can you predict in advance what it will look like? What if we skip by 4 and 5 and 6? And so let me just do a couple other skip numbers right on here with the 13. So let's say we decide, I'll pick a new color. Let's do 13 people, but let's do every 5th person. How is that going to look? Is it going to be different or the same? What will it look like? Let's find out. So 1 is going to skip 4 people and throw it to 6. So 1 throws to 6. So we're just adding 5. So 6 is going to throw to 11. 11 is going to throw to 16, but we don't have 16. So 1, 2, 3, 4. I guess that's 3, which happens to be 16 minus 13. So it's this is modular arithmetic like a clock. So 11 is going to throw to 3. 3 is going to throw to 9. 9 throws to 15, but we don't have a 15. But 15 minus 13 is 2. So 9 is going to throw to 2. 2 is going to throw to, I forgot my skip number, 7? Yeah, that's right. 7 throws to, 7 throws to 12. 12 throws to 17, which is 17 minus 13 is 4. 4 throws to 9. Uh-oh, did I mess up somewhere? I might have messed up. Oh, I hate when that happens. 1 throws to 6, throws to 11. Does 11 throw to 2? Wait. Did I mess up, team? I might have messed up. Oh, 3 was supposed to throw to 8. The beauty of Notability is I can just rewind. Hate when that happens. We all make mistakes. 3 throws to 8. 8 throws to 13. Yes, much better. 13 throws to 5. 5 throws to 10. 10 throws to 15, which is 2. Then to 7. Then to 12. 12 throws to 12 throws to 17, which is 4. Goodness, this is harder than it looks. There we go. Okay, not the prettiest picture. Thank you for fixing my mistake in the chat too. So I will print out circles with different numbers of dots and let students explore smaller numbers. So obviously with really big numbers, you make mistakes like me because I'm human. But I might start with like 7, put 7 dots on a circle, put 5 dots on a circle, pick a skip number like 2 and see what that looks like. Let's just do 5 and 2. There's 5. If we throw to every second person, we get that. You might have seen that shape before. You might have even learned how to draw that shape without ever thinking about how it was made in this kind of fashion. Now, another thing that's kind of cool is what if we did 10 dots and we went to every 4th person? Let me see if I can do 10 dots. I'll start by making 5 dots and then I'll put ones in between. That'll give me 10 dots. And I'll go every 4th person. So 1, 2, 3. Wait a minute. Did I make 10? 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, every 4th person. So like this, and then like that, and then like this, and then like this, and then like this. What? I just got the same picture again. How does that work? So there's lots of really cool things to explore. And then I just want to share one more thing with you, because when I did this with students a couple of times, they were so into this, they couldn't stop asking questions about what does it look like? How many points is it going to have? What pretty pictures can we make? So I discovered that someone had made this on Desmos. So let me see if I can share that with you real quick. Here we go. And I can put this in the chat. So let me stop sharing this and start sharing my web browser. Hang on one sec. There we go. Okay, this should show up on your screen. And this is really cool. I can manipulate how many points I have, how many people are in the circle. So I'll go to something Let's go to something big. Let's do like 20. We'll do 25. There's 25 of us. And you can then choose the skip number, and you can see all these beautiful stars show up. It's super cool. Now, this just kind of gives it away because as soon as I change this number, you get a new star. But there's also this timer that you can play. So if you play this, if you started at 0 and hit play, you can actually watch the ball go around. It's like a spirograph. It's mesmerizing. It's super cool. And one of the neat things to do would then be to figure out, can you guess what it's going to look like? If I choose 25 and 8, will I get all the people, or will it not touch all the people? What if I pick 25 and 5? Whoa, pentagon. Did not expect to see a pentagon here. Why is it a pentagon? And how is that similar to if I did 5 people and skipped to every first person or every second person? We know that looks like a star. Every third person looks like a star. Every fourth person looks like a pentagon again. What? There's so much cool stuff you can explore here. And this just kind of, you can decide if you think this is making it too easy or just right. Depends on where you want to go. Sometimes technology is our friend, and sometimes it makes life too easy. But I will share this link in the chat. So let me put that in our YouTube chat. Let me stop sharing that. But I could not get kids to stop drawing star polygons when I showed them this Desmos. And thank you for showing me grace about making mistakes. Absolutely. I definitely made that mistake on purpose so that you could all see that we all make mistakes. I actually don't have to try very hard to make mistakes. There's the chat. Put the Desmos calculator there in the chat, so you can play around with that on your own as well. And let me know right now if you have any questions or comments. Have I given you any inspiring questions to start the year off? And we have some time left, so I'm happy to do 1 or 2 more of our choose your own adventure problems. I'll put that on the screen while I wait for you to tell me a little bit about where you're at so far this morning, this afternoon. And side note, that star polygons thing is going to get us back to talking about factors and multiples. So it's kind of a neat way to dive into factors and multiples that you wouldn't know. You wouldn't think at first that they matter, but they do. So someone's asking about where the list of problems. This YouTube thing will be stored, so you can always come back to this, and it's going to stay on the internet forever. Oh, thanks for asking about how I end. I haven't talked about that too much. Oh yeah, you can, in the Desmos calculator, you can actually make the skip number a decimal and get all kinds of crazy stuff. Okay, so how do I like to end? At the beginning of the year, I'm not super concerned about like having a deep discussion about factors and primes or factors and multiples or whatever. I am more interested in talking about like what are the problem solving strategies that we used, and how do they connect to each other? If you've read the 5 practices for orchestrating productive mathematics discussions, I think that's the right title. Mary K. Stein and Peg Smith. That's a great resource. So I kind of think back to that of how do I help them make some connections, and just also talk about like emotionally, what did it feel like? Was there a point where you were scared, worried, nervous, anxious? What did that feel like? How did you work through it? How did we work through it together? Because we're going to need those skills, those soft skills later in the year, because we are going to be tackling problems like this all year long. And we should expect to be stuck and that's okay. But let me make that more concrete. Let me do the math magic and then bring it back together. So probably I've been doing this math magic problem in a lot of my presentations lately. So many of you have probably seen it. Is there anyone here who hasn't seen the 4x4 math magic grid that I have up on the screen? Because if you haven't, I need you to be my volunteer. And while you do that, I'm going to switch back to my iPad screen. So let me do that. And then someone who hasn't done the math magic trick with me, volunteer that in the chat. This is one of my favorite tasks, and I feel like it works for pretty much any grade that you can think of. So let me get that on the screen and try to do two things at once. Try to get that up there and also monitor for someone who hasn't seen this before. What I do is I draw a 4x4 grid. And bear with me while I do that. And we're just going to place the numbers in order, top to bottom, left to right. Oh, good, Mallory, you haven't. Awesome. You just became my guinea pig. Thank you so much for being brave. So I love this, one of my absolute favorites. Okay. Emily, you can help out too. So first thing I want to do is just like, what do you notice? Before we even get into any magic here, what do you notice? And you might immediately notice that there's 16 squares in my grid. Yes, indeed there are. And the numbers go top to bottom, left to right. Awesome. What are some other patterns that you notice? I'm going to spend a little bit of time here just making sense of the matrix and not taking it for granted right off the bat. And so type for me in the chat some things that you notice beyond the 2 or 3 that I've said already, or things you might think students might notice. Maybe some connections between the numbers in the grid. Even in odd columns, yeah, it's a common thing. I never notice even in odd patterns, but people do. So this column is all odd numbers, and this column is all odd numbers, and this column is all evens, and that column is all evens. Yeah, cool. And the rows are in groups of 4. If you go down one row, so if you're here and you look down one, you're adding 4, right? As you go down the matrix, you add 4. All the numbers, this is awesome. You guys are fantastic. All the numbers in the right-hand column are straight up multiples of 4. Yes, this is good. Awesome. So I like to notice those things first because those are going to help us later. Now let's get into the magic. I'm going to do some amazing magic for you. What I will do is I will allow Mallory and Emily, you're both going to be my volunteers. I'm just going to pick the first numbers that I see as they pop up in the chat. What I want you to do is you're going to pick 4 numbers from this grid. And I, right now, am going to predict the sum of those 4 numbers using my magical mathematician skills. I'm going to write that on a piece of paper in Sharpie. So I've written that on my piece of paper. I'm going to fold it. And I'm going to hold it on screen so that people know that I have not cheated and I'm not like writing down the sum later. Now, if you could pick any number from the grid, any number, and type that in the chat. I'll give you free choice, 1 through 16. All right, I don't see anything in the chat yet. I'm just waiting. There we go, 11, awesome. Emily, go ahead and punch. Well, let me tell you one thing. If you pick the 11, there's your 11. What we're gonna do is we're gonna cross out all the numbers that are in the same row and the same column as the 11. So that's off the table. But you've chosen 11. Fantastic. And then I see Mallory's given us a number that we're allowed to pick, which is 13. So we're going to take the 13. That's going to go into your column. That's your second number. But we have this one rule where we're going to go ahead and cross off everything in the same row and the same column as 13. And now you guys have free choice of anything that's left. So what's left? 4, 2, 4, 6, and 8 are left. You free choice of any of those 4 numbers. Okay, awesome. Thank you, Emily. You're going to take 6. I had a feeling you would take 6. I'll cross off that column and that row. And then I don't need you to volunteer for the last number. It seems you have one choice. You're going to take the 4. Awesome. There's your 4 numbers. We're going to add them up. 10 plus 10 is 20. 3 plus 1 plus, I think, wait a minute. Did I mess something up? No, 20, 30, 34, 34. Excellent. There's our sum. We add them up. Now, the question is, what did I write on this piece of paper? So hopefully you guys can see me on your screen big enough. I'm going to reveal. You can tell I did not mess with this paper the whole time. And hopefully this will show up on the screen clearly. It's a little sloppy and upside down. Hello. There we go. 34. So you should be amazed right now. How did I know that you were going to get 34 as the sum of your 4 numbers? I have done this with first and second graders. I've done it with middle schoolers. I've done it with teachers. People are always amazed that it works. How does it work? And then the next question is, okay, we probably know this guy is not magical. So what is going on? And we might try a few examples. So I would then let you draw your own 4x4. I put you in groups and play around with this and try some other things and see what happens. Students will soon discover that as long as they follow this rule of basically picking one number in every row and every column, which is what we've done here, by crossing off things as we go, I've forced you to pick one number in the first row and one number in each row and one number in each column. So do those always make 34? You can play around with this. You will discover, in fact, we can just do one more example real quick. Let me zero out my board here, and I will pick the numbers this time. I'll pick 1 and then cross off that row and column, and then I'll pick 6 and cross off that row and column, and then I'll pick 11 and cross off that row and column, and then I'll pick 16. And if you add these up, I can guarantee you're going to get 34. So then they'll be like, oh, whatever. It's not magical. It's just always 34. Yeah, that's true. But why? And then we try and figure out like what makes 34 the special number for this magic trick. And there are many, 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 many ways that we can attack this. So I will let them go off and try to play around with this and figure it out. One way you could attack this, which we've already done kind of, is guess and check. Like just pick a bunch of options and you keep getting 34. Well, that's not a proof, but it certainly will lead you to the conjecture that you always get 34. Well, could you do all the examples? I guess you could. It'd be a lot to think through, but you could do it. Let's just say you pick 1 the first time, right? Let's say 1 is your first choice. Well, what then are your options after that? And we'll kind of go row by row. So let's pick a number out of the first row. That's 1. Then let's pick a number out of the second row. Well, now 5 is now not an option because it's right underneath 1. It's crossed off. But 6, 7 are options. So I could kind of make myself a little tree where 6 is a choice, 7 is a choice, and 8 is a choice. Let's suppose I pick 6. Then what can happen? Well, now I'm restricted to, in the third row, only 11 and 12. So I only have 2 branches from there. And then if I've chosen the 11, I can only choose the 16. If I've chosen the 12, I can only choose 15. And we could kind of fill this thing out and convince ourselves that, gosh, whatever we do, if we pick one, we're always going to get 34. And you could repeat this and effectively do all of them. That's an option. Is it the best option? I don't know. But that's one. So you were asking me, how do I tie this all at the end? So if no one does this, I might go around the room if I have small groups working and just be like, hey, have you thought about maybe like, what if you picked one? What are your other choices? And kind of filtering it down that way. So I kind of try to plant different seeds around the room of different ideas if they aren't already naturally blooming and growing. Because sometimes kids will just get stuck on just trying random choices over and over and over again. So I try to give them some structure for that. That's a seed I might plant. Or now that we have this example of the diagonal, what if you move one of them? So what if I decide, you know what? Never mind. I don't want the 6. So let me just write my original choice was 1, 6, 11, and 16. I don't want the 6 actually in the second row. I want the 8. So I'll go ahead and I'll keep the 1, but I want to change my 6 to an 8. Okay. Well, good news. You can keep the 11 because it doesn't conflict with the 8, right? It's not underneath the 8. So the 11 can stay. But the 16, I'm not allowed to pick 16 if I've picked 8. That's gone. What I would be allowed to pick, is the 14. So this would now be available to me. So I would pick 14. Now, what do you notice about those two choices? Well, the 6, when I switched it to the 8, I had to add 2. But then I lost the 16, and that gave me the 14, which subtracted 2. Ooh, what's going to happen to my sum? So thinking about an alternate choice could be another way you think about this. Does that always happen? If you move one of them, does another one have to sort of move and compensate exactly in the other direction? Don't know. Play around with that. So that's a second way you might tackle this. There's lots of other ways to think about it. There are some algebraic ways you could think about it if you're teaching higher grades. We could assign variables and talk about it that way. There's a lot that you can do. So I try to plant these seeds around the room. And then when we've gotten to a nice spot where things are slowing down, the thinking is starting to slow down, or some people have some really good ideas, I'll pause everyone and then select a couple of groups to share. Like, what did you do? Oh, we drew this little matrix or this little tree. And we kind of convince ourselves that it always ends up being 34. Or we switch some numbers around. And we notice that when you move one number, you got to move the other number in the opposite direction, the exact same amount. So that was another way to do it. And then we'll just try to draw connections between those ideas. Let me throw another couple strategies at you just for fun. If a group is stuck, this is too confusing. My favorite strategy that I feel like students don't use often enough is solve a simpler problem. What if we just made this really simple? What if instead of a 4x4 grid, this is going to sound crazy, but I started with a 1x1 grid and I just put the number 1 in there. And I said, you can pick any number you want from this grid and I will guess the sum of that number. Obviously, you're going to pick 1 and I know the sum is going to be 1. Okay, that's not a very good magic trick. Let me make this a little bit bigger. Let's do a 2x2 and we'll fill it in the same way. One top to bottom, left to right. 1, 2, 3, 4. Okay, what are the options here? Well, you could pick 1. If you pick 1, then you have to pick 4. So you have the choice of 1 and 4, which make 5. Or your other option is you could have picked the 2, in which case you have to pick the 3, and that adds to 5. Starting to see that same structure of when you switch, things kind of compensate for each other. But I kind of know the magic sum for a 2x2 grid is now 5. Let me try 3x3. Okay, what's one choice? Well, I could go down diagonal again. That's 14. I could try a different, maybe I choose 2 and 6 and 7. wait, did I say 1 plus 5 plus 9 was 14? Ah, there's me modeling mistakes again. That's 15, isn't it? And 2 plus 6 plus 7, that's also 15. So we could, here we could really do all of the options because there aren't that many and discover the magic sum is 15. Now we're starting to see, like, maybe we'll see a pattern with these. We know the magic sum for a 4 by 4 is 34. So we can start to look at like differences. So there's so many like pattern things we could do here. Now, here's one interesting pause I would do on this. Let me go back a tiny bit. Once I've selected the 1 in this matrix, I then cross off these, and I have this matrix, this 5, 6, 8, 9 matrix. Now that looks kind of like this one, doesn't it? It's like a 2 by 2. And you notice that if I go 5 and 9, that's 14. And if I go 8 and 6, that's 14. That's a lot like this 2 by 2 grid that I solved before. And if let's just say I picked 5 first, and I know that's not in the first row, but let's just pretend like I picked that. And then I cross off 2 and 8, 4 and 6. Now what's left? Now I have 1, 3, 7, and 9. And you'll notice I could pick 1 and 9, which make 10. And I can pick 3 and 7, which make 10. So weirdly, when you pick your first number out of this 3 by 3 grid, you kind of get this magical 2 by 2 grid. It doesn't look exactly like this one, but the diagonal sums are always the same. That to me is pretty fascinating. I would not have guessed that right off the bat, that diagonal sums are the same. What's the structure? Well, when you go down from 1 to 7, you're adding 6. When you go down from 3 to 9, you're adding 6. When you go to the right from 1 to 3, you're adding 2. When you go from to the right, you're adding 1. And you all noticed that right at the beginning. You were telling me, hey, when you go down a row, you're adding 4. And when you go over 1, you're adding 1. So as long as we maintain that structure, it seems like we get these little grids that have these diagonal sums that are always the same. So that's another way to sort of attack this problem. And you can kind of see how it connects back up with some of the other strategies. So that's how I like to end it. I like to end it with, there's like, hey guys, there's multiple ways we can attack these. Which ones do you like? Which ones don't you like? And then we could extend. What does a 5 by 5 grid look like? Will be the numbers 1 through 25. Every time you go down a row, you're adding 5. Every time you go over a column, you add 1. What would its magic sum be? And then if you're working with algebra, you could even go to what's the magic, oh, not with that marker. You could even think about what's the magic sum for an n by n grid, which is a really cool task. So that gives you some extensions. If kids figure things out really quickly, you can have them do 5 by 5, 6 by 6, and then challenge them to see if they can find the structure of what goes underneath that. So that seems like a reasonably good place to pause and see if you have any other questions, comments. Are there any of these that you feel like, oh, I'm going to use one of these week 1? And if so, which one? So I'll open it up for questions and then we will wrap up. Any questions or comments? Put those in the chat for me. Okay, question about the answers. And yeah, the magic square, I tell you what, it's gold with elementary students. Um, it doesn't fail me. And it works for it works for adults too. People are amazed by it. And then there was a question about, do I have these posted on YouTube? So I thank you for saying that, because I don't know how many of you know, but throughout this crazy pandemic, I have been posting what I call math treats on YouTube. Um, there's the channel. It's on my channel. You probably have access to it already if you're on YouTube right now. And I only post the question stems. Every once in a while, I will post a hint. I never post the answers. I also try to make the titles ungoogleable. Is that a word? So that people can't just zip on over to find the answers. So for example, I call that game Take the Last One. It's actually NIM. But the reason I call it Take the Last One is that you won't be able to Google it very easily. Now, sometimes teachers find that frustrating because they want to know the answers too, but I don't believe in telling a lot of answers. So if you're looking for more ideas, you can definitely check out that part of my YouTube channel. There's all kinds of stuff there. And if you ever want more details or like ideas, or that seems like a cool problem, but I don't feel comfortable launching it with my students without like really investigating it first, you can send me an email or hit me up on Twitter, and I'm always happy to help out with more details and things like that. Okay, cool. I'm glad some of you are using the math treats. Please do keep using them. And if you have any ideas for making them better, send me an email. I definitely am not going to be posting the answers. I've thought about having an answer website where you have to like type in some sort of proof that you've done the work before I show you the answer. But I do think for teachers, it would be valuable to have some ideas for like, what are some ways people can attack this problem and things like that, just to make it easier for you to use in class. Okay. I'm here for a few more minutes. If anyone has any other questions or comments that I haven't answered. Yeah, Melissa, I appreciate your comment too about, I just feel like at the beginning of the year, we have more freedom. It's a little bit of space to do some of the things we might want to do during the rest of the year, but maybe feel like we can't. And I hope if, you know, that this is going to prepare them for being in those productive struggle situations later when there are more curricular-based relevant tasks. All right. Well, the link that you used to get here should continue to work. So you should be able to come back to this and reference it. And as always, if there's anything I can do to make your life better, just let me know. Happy to do it. I know life is hard for all of us right now, so I'm just trying to do little things wherever I can. Thank you for sharing your afternoon with me. Enjoy the rest of your weekend. Feel free to share this YouTube link with your friends. And remember that if you want, I do visit schools and classrooms. So if that's something of interest to you, let me know that too. I'm happy to share this with other folks in your building and school district and all that other stuff. And as always, have fun playing with math. Until next time. Bye.